Okay, today we're doing section 2.3, graphing linear functions. We're only going to be working on examples 4, 5, and 6 in the book. Example 4 talks about graphing functions in slope-intercept form. Example 5, graphing vertical and horizontal lines. And example 6 is your all favorite, word problems. The slope-intercept form looks like this. It's y equals mx plus b, where m is your slope and b is your y-intercept. And the y-intercept is where the line crosses the y-axis. Okay, if you get a line, this is b, and your slope is the slope of the line. We'll go over that more. Review. What is slope? Slope is called the rate of change, and there's a lot of ways that we'll talk about it. We can talk about it as the change in y over the change in x. That means you subtract the y's, you subtract the x's, because you're going to have ordered pairs on a line. A line consists of 2 points, x and y and x and y. Okay, that's 2 points on your line. X and y, 2 points. So you subtract the y's and subtract the x's, and in fraction form, we're going to leave it in fraction form, it becomes a slope. We also talk about it as rise over run. That means we're going to rise and run. We're going to rise from one point to another and then run left and right. Also talk about it as change in f of x over change in x, because remember, f of x and y are interchangeable. Okay, also talk about it as y2 minus y1, y2 minus y1 over x2 minus x1. You'll also see me write it like this. Change in y over change in x. This little triangle thing is shorthand for, change. So that means change. So change in y over change in x. y2 minus y1, x2 over x1. You always do it in the same order. So our review. Continued. What are the x and the y-intercepts of a line? You have your axis and your line. Okay, where your line crosses the y-axis is called the y-intercept. And it is written just y. 0, y is the y-intercept. You didn't go anywhere in the x-axis, you just went up. So 0, y. Your y-intercept is just the y. It's a single value, not an ordered pair. The x-intercept is where your line crosses the x-axis, which is x0. You go over in the x direction, you don't go anywhere in the y. But the x-intercept is just a value, a single value, not an ordered pair. Graphing functions in slope-intercept form. Most graphing calculators require equations to be solved for y. So slope-intercept form is the easiest to enter. Y equals mx plus b. M is your value, a slope, usually a fraction. B is your intercept, the y-intercept, where it crosses the y-axis. Example, write each function in slope-intercept form, then graph the function. So we need slope-intercept form, y equals mx plus b. Okay, we're going to do some algebra. I'm going to subtract 3x from both sides because it's currently positive. Subtract 3x from both sides. I'm left with y equals negative 3x plus 5. Slope-intercept form. M, which is your slope, is negative 3. B, which is the y-intercept, is 5. All right, you just solved it for y equals negative 3x plus 5. That means our y-intercept is 5 and our slope is negative 3. So to graph it, you always graph your y-intercept first. Sorry, your slope. Let's get a negative in there. 1, 2, 3, 4, 5, put a dot. And our slope, rise over run, -3, there's always a 1 in a fraction, so -3 over 1. Rise over run. Okay, our rise is negative, so we're going to go negative 1, 2, 3, positive 1. Negative 1, 2, 3, positive 1. And draw a line. At this point, I'm going to tell you guys, you must use a ruler, straight edge of some sort, either a ruler, a note card, something straight that can graph you a straight line. This is not a straight line. I want you to graph a straight line. Okay? I won't be accepting papers without with lines drawn without a ruler. Another example, write each function in slope-intercept form, then graph. Okay, I have y equals x minus 3, but I have a number in front of the y. I have to get rid of that number. Okay, to get rid of a fraction, you're going to multiply by the reciprocal. Multiply by the reciprocal. Okay, these all cancel out, and you're left with y equals, notice I've put this in parentheses, distribute it, 2/3 x, 2/3 times 3, it's 3 over 1, 3's cancel, and you're left with 2. So 2/3 x minus 2. Graph it. So y equals 2/3 x minus 2. Your slope is 2/3. Your y-intercept is -2. Graph it. We always graph the y-intercept first. -1, 2, put a dot. Slope. Rise over run. I rise 2, positive direction 1, 2, positive direction 3, 1, 2, 3. Okay? I want to look at this slope. 2/3 is the same as -2/3. -2, -3. Okay? Let me say that again. 2/3 is the same as -2 over -3. So if we started our y-intercept and go in the negative direction 2 and the negative direction 3, it's the same. Everything's on the line. And you're going to draw a straight line with your straight edge. Okay, you try it. I'm going to push pause, and you need to solve this for slope-intercept form and graph it. All right, I solved for y. Please note, y is negative. Okay, y is negative, so I multiplied the entire equation by negative, changed the signs. Positive y, positive 2x, -9. Graphed it. Y-intercept to -9, slope of 2, positive 2, positive 1, positive 2, positive 1. You try again, same instructions. Okay, I subtracted 30 from both sides. Okay, and rewrote it. Yes, I rewrote it backwards because I like my y on the left. Y equals mx plus b. So 15y equals 5x minus 30. Divide everything by 15. Those cancel out. I'm left with 5 over 15x minus 2. 30 over 15, 2. 5 over 15 reduces. 5 goes into 5 once. 5 goes into 15 3 times. That's what I'm graphing. Y-intercept to -2. Slope of positive 1 over 3. Positive 1 over 3. All right, vertical and horizontal lines. This is very important. Vertical line. The line x equals a is a vertical line at A. This one is x equals 1.5. This is the equation for the line. So I go to x, my x-axis, 1.5. Put a dot and draw a line. X equals 1.5. Y equals 3.5. That's why the line y equals b is a vertical line at B. B is your y-intercept. We just defined that. So for this line, I go up 1, 2, 3.5, put a dot, and draw a line. This equation is y equals 3.5. This is really important too. The slope of a vertical line is undefined. So let's draw x equals 2. 1, 2, put a dot. Draw a line. I'm going to pick 2 dots on this line, 2 points. This is 2, 2, 1, 2, 1, 2. and this is 2, negative 1. Let's calculate our slope. Okay, it's change in y over change in x. I'm going to subtract my y's. 2 minus a negative 1. 2 minus a negative 1 over 2 minus 2, my x's. That gives me 3 over 0. I cannot divide by a 0. Dividing by a 0 is undefined. Okay. The slope of a horizontal line is always 0. Let's graph this line. Y equals negative 2. Down 1, 2, put a dot, draw a line. I'm going to pick 2 points on that line. Negative 3, negative 2, 2, negative 2. Calculate my slope. Change in y over change in x. Okay. Negative 2 minus a negative 2 over negative 3 minus 2. It does not matter what order you subtract in as long as you're consistent. I did negative 2 minus negative 2, negative 2 minus negative 2 over negative 3 minus 2. Okay, negative 2 minus a negative 2 is 0. Negative 3 minus 2. Okay, 0 divided by 5 is 0. The slope is 0. Problems, example problems. Determine if each line is vertical or horizontal. That means graph it and tell me. Vertical, horizontal. X equals negative 2. X-axis. Oh, goodness. Okay, x-axis. This is my x-axis. So go to x equals negative 2, put a dot, and draw a line with your straight edge. Okay, this line, x equals negative 2, x is negative 2 everywhere on that line. No matter where you go, x is negative 2. Let's clean that up a little bit. Okay, to draw my line, negative 2. Y equals 4. Okay, we're going to go to y, the y-axis, and go up 1, 2, 3, 4. Put a dot and draw a line. So this one is vertical, this one is horizontal. You try it. Determine if each line is vertical or horizontal. There you go. X is negative 5. Sorry, y is negative 5, x is 5. Y is in red, x is in blue. Alright, word problems. A ski lift carries skiers from an altitude of 1,800 feet to an altitude of 3,000 feet over a horizontal distance of 2,000 feet. Find the average slope of this part of the mountain and graph the elevation against the distance. Like I told you yesterday, I need pictures. Okay, I've got a mountain. It's blue. Okay, it continues on, but I have a ski lift. Okay, my altitude here is 1,800 feet. My altitude here is 3,000 feet. Okay, horizontal distance, 0 to 2,000 feet. Okay, I have 2 points. I need the slope. Change in y over change in x. Still, I've got y goes up and down, x goes left and right. So if we have change in y, which is the up and down, my slope is 3,000 minus 1,800 over my horizontal distance. 3,000 minus 1,800, so I did 3,000 minus 1,800, so I need to do 2,000 minus 0. You have to be consistent. Okay, if you do the math here, you actually get 0.6 in your calculator, but slope has to be in fractions. So either hit your math frac button or do 0.6 is 6/10, which equals 3/5. That is your slope. Okay, you also need to graph it. Here it's been graphed for you. You're going to pick a scale here that makes sense. Your scale has to make sense. This is your altitude. So this is where the ski lift is starting. This is where it's ending. You're going from a horizontal distance of 0 to 2,000. And your altitude goes from 1,800 to 3,000. So get some regular graph paper out, make a scale, label it, pick a scale that works. You do not always have to start at 0, and try to make your graph. A truck driver is at mile marker 624 on the interstate. So he's driving down the interstate. And then when you're driving, you'll see that there's little mile markers along the side of the road. So he looks up and he sees I'm at mile marker 624. He drives for 3 hours. And then he looks up and he sees that he's at mile marker 432. Okay, find his average speed. Average speed is miles per hour. Miles per hour. So we need the change in miles over the change in hours, the change in distance over the change in time. 432 minus 624. That gives me my change in miles. Okay, I'm at 192 miles. That's the distance he drove. Okay, you can't think positive and negative here because this is distance. Distance is always positive. Direction is positive and negative. Time, that would be 3 hours. So his rate is 64 miles per hour. Change in distance over change in time. Okay, graph his location on I-10 in terms of mile mark. So, I'm going to do an X and a Y axis. Okay, time and distance. Okay, if we do, actually it'll be easiest if we do sort of the slope. So I'm going up by 64s because it's going to be easiest to graph. If you don't, no big deal. Estimate your dots. It'll be good. So 1 hour, 2 hours, 3 hours, because it's only for that time that he was in the car. So if we start at 0 and then we use our slope, 64 over 1 plus 64 over 1 plus 64 over 1. That gives us, okay? All right, that's all I have. Come in tomorrow for classwork and your daily check.